Hey, welcome back, Algebra 2 students. Today we're looking at 4-14, quadrilaterals. Yeah, just a review of stuff that we learned earlier in the year and you guys did partially in Algebra 1, getting ready for your exam. So the first one says to solve 4u squared equals negative u plus 3. So the thing to remember about quadrilaterals is we have to make them equal to 0 in order to solve them. So we're going to move our u and our 3. So we get 4u squared plus u plus 3 equals 0. And now anytime we have a number in front of our variable squared, it makes it a little bit harder, but we'll review this way of factoring. So what we want to do is we want to multiply the first and last numbers first. So 4 times 3 is 12. So we're looking for a number that multiplies to get 12 and adds to get this middle term, which we don't have, but we know is going to be 1 because we have a u there. Oh, sorry, this should be a minus 3. So this is a negative 12 minus 3. Okay, so the two numbers that add to get 1 and multiply to get negative 12 are positive 4 and negative 3. So we're going to set up our parentheses, and this is a little different. Some of you guys might have learned to factor using the box method. I find this one is a little bit cleaner. So what we're going to do is we're going to put that 4u in both of the boxes. So whatever is your leading coefficient, we're going to put in both boxes, and then we're going to put our plus 4 and our minus 3. So if we can divide it by the 4, then we're going to do so. So in the first one, we can divide both terms by 4. So 4n divided by 4 is n. 4 divided by 4 is 1. So that simplifies out. The second one, we can't divide by 4, so we can leave it as 4u minus 3. All right, if it asks you to solve, we're not quite done yet. We factored it, so we've got to go figure out what makes these 0, each of these parentheses 0. So let's go ahead and do that now. The first one is easy. We know that if n is negative 1 and we add 1 to it, we get 0. So, oh, sorry, this should be u. Okay, so u equals negative 1. Now the second one, we might have to do a little bit of solving. So 4u minus 3 equals 0. We're going to add our 3 to both sides. So 4u equals 3. And then when we divide by 4, we get 3/4. And then we'd be done. Okay, on to the second one. So for this, it's asking us to graph our quadrilateral. So the key here is, because we have this in standard form, what we want to do is we want to locate the vertex. So we're going to do the vertex. And to find the vertex, well, the x for the vertex, we're going to do negative b over 2a. So remember, every time we have a quadrilateral or an x squared situation, our a is the leading coefficient, our b is the x, and our c is the constant, the number without a variable. So we're going to plug that in here. Negative 10 over 2 times a is negative 1. So that's going to be 10 over negative 2, which is negative 5. Okay, so this is our x, keep in mind. So when we do our graphing, what we're going to do is we're going to calculate our x's. We're going to put this negative 5 as our middle x term. And we're going to do 2 less than and 2 greater than. And then all we do is substitute our values in there and then plot our points to graph. Right, I'll do 1 or 2. So we're going to plug in negative 7 to our equation. Negative 7 squared is 49. And then minus 10 times negative 7 is 70. and then minus 21. So that would be 49 plus 70 is 21, minus 21 is 0. Then we can do the next one, but you guys kind of get the idea here. So then we have negative 36 plus 60 minus 21. So that's going to be 24 minus 21 is 3. Okay, and then you continue and then you plot all your points out. All right, for number 3, we have f of x equals 2x squared minus 4x minus 1. And what it's asking us is this a min or max? Okay, so we're looking at the leading coefficient. Anytime we have a positive quadrilateral, we know it's opening upwards. If it were negative for our leading coefficient, then it would be opening downward. So in this case, it's positive. It's opening upward. Therefore, we have a point on our parabola, which is the lowest point that we have. So this is going to be a minimum. Now it asks, where does the min or max occur? So we're going to go back to our vertex, right? We want to find our vertex, so we know we're going to do x equals negative b over 2a. So our b is negative 4, and our a is 2. So negative 4 is positive 4. And then divided by 4 is 1. Okay, so we know where is asking us what x value. So we found that, right? So it's at negative 1. Now the second part, or the third part, is asking us what is the min max value. So at x, at positive 1, what is the value there? So we're going to do f of the value we found here. F of 1 is 2 times 1 squared minus 4 times 1 minus 1. So we'd get 2 minus 4 minus 1. So that would be negative 3. Okay, on the next one, so these ones deal with completing the square. So for this number 4, it's asking us make a perfect square. So here's the thing, what we're going to do is we're going to find the middle number. So we have negative 10. We're going to divide it by 2 and square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So the whole idea about making it a perfect square is if we were to factor this would factor to w minus 5 times w minus 5, which is w minus 5 squared. And we're going to see how we apply that in the next problem when it's asking us to complete the square. Okay, so number 5, it says solve by completing the square. So we're going to do what we did in the top. We're going to leave this blank here. And then we're going to put a blank here too, I guess. You don't have to, but I'll do it so you see that we're balancing it out. So we're looking at the middle term again, negative 16x. So we're going to do negative 16 divided by 2 squared. Negative 16 divided by 2 is negative 8. Squared is 64. So notice we're balancing out because we have an equation this time, right? So if we add 64 to one side, we've got to make sure that we add 64 to the other side. So now the whole reason we did this completing the square part is because when we factor this, it's going to be x minus, right? We take the sign here, minus 8 times x minus 8. Then we have this plus 54 equals 0 plus 64 on the right hand side is 64. Now this thing is going to be x minus 8 squared. we can subtract the 54 from both sides at this point. Actually, rather than subtract 54, I know we're used to moving everything to one side, but we're just gonna save some steps here and we'll move the 64 over. So then we get 0 on this side and we get -10 on this side. So this is in vertex form. Okay, and then we can solve it from here. So it's asking us to solve, right? So just because we get it into vertex form, we're not quite done yet. What we're going to want to do here is we're going to take our 10, and I guess we added 10 to both sides anyway, so we could have done what we were doing originally in the previous step, but that's okay. We have 10, x minus 8 squared equals 10. Now we just solve algebraically, so we're going to square root both sides. Keep in mind though, the squared and the square root cancel out, but anytime we take the square root of something on the right hand side, or any side actually, we have to make sure that we do the plus minus. So we have positive -10, excuse me, on the right side, and then on the left side we have x minus 8. And then our last step is we're going to add 8. Now remember, we can't just add 8 into the radical, so those two are two separate things. So we have 8 plus or minus square root 10. And then that would be your answer. Okay, on to the next one. Number 7, it says use quadratic formula. So let's write the quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. And then we referred to this earlier, so we'll label our a being, oh, before we do that, we gotta make sure it's equal to 0. So we'll move our 3 over. So we have 3x squared plus 5x minus 3 equals 0. And at this point, we can start substituting our a, b, and c. So we have negative b is 5 plus or minus square root of 5 squared minus 4 times a is 3 times c is -3 all over 2 times 3. And we're going to start simplifying. So I should have left a little bit more room, but we have -5, 25, and then this thing is 4 times 3 is 12 times 3, -3 is -36, so 25 plus 36, this is going to be square root of 61 over 6. And because we can't simplify, 61's a prime in our square root, we'll leave it as that. Okay, and then number 8 pretty much goes along with this. So we can't factor, well, no, we can't factor this, right? So it's asking us to find complex solutions. Remember, complex solutions are imaginary, so we're going to end up with some negative square root in there, or we're expecting to end up with some negative inside of our square root. So let's do our a, b, and c. Because most times we are finding complex solutions, we're going to be using the quadratic formula because we can't factor them. So let's do negative b is -1 plus or minus square root of -1 squared minus 4 times 3 times 1 all over 2 times 3. So let's clean this up. -1 is +1. Plus or minus, we have 1 minus 12, which is -11 over 6. And remember, anytime we have a negative inside our square root, we can treat that, we can make it an I. So we're going to say 1 plus or minus square root positive 11 because we're taking the negative out and we're saying it's an I over 6. Okay, so one of the big new things that we learned in Algebra 2, right? So we can have imaginary numbers if we have negatives inside of our square root. Okay, so that's it for today. Hopefully this refreshes your memory so that we can do well on our end of course exam. Good job.